get this party started. This is Paul. He had a crazy idea.
Yeah.
And then he did it. And now he's going to tell us about it.
Yes, Lisp, in fact, is that language. Can everyone sort of hear me? I'm kind of loud, so you should be able to hear me. No. You can? No, you can't. No, well, you heard what I said. Enough to say no. Okay, so I'll try to stand near here, I guess. All right. So unlike the last presentation, this will not make you lots of money, and it will not make me lots of money. And this most certainly is not ready for any sort of production. So if anyone tries to use this in production, I will like stroke out immediately. So treat this more as
I'm
like,
deploying it now.
yeah, exactly. Yeah, no, it's terrible. No, I love what's going on here, but I'm probably going to rewrite it, so it's probably going to break terribly. And it's more of like a neat learning experience more than it is like something practical. Because like honestly, there isn't much of an advantage over Python right now, but it's still something we should talk about because it's awesome. If you want to check it out, you can go to git.io/hi. That will take you to the GitHub page, and you can start it and take a look at how things are working, or contribute if you want, whatever. So who out there knows Lisp right now? You know Lisp, you know Lisp, Lisp. We have so many Lispers, this is awesome. Okay, and who knows Python? Woo! Woo! All right, cool. Does anyone know like eLisp, the Emacs Lisp?
I wrote a
People with beards are saying yes. Okay, good. Okay, all right, yeah. All right, so what about Common Lisp? Common Lisp variant, Common Lisp, Scheme, Closure. Closure is awesome. Anything that I haven't mentioned that anyone wants to yell at me for not mentioning? Mac Lisp is like eLisp. Mac Lisp is very similar to eLisp, so I'm not going to say.
I know Lisp and Visual Lisp.
Okay, all right. Well, so I really
And
like.
he's wearing a tie.
You are wearing a tie. I'm surprised that you know how to write Lisp. I like it. Okay, great. So for those of you who don't know what Lisp is, it's like a fantastic language. It's like great. Everyone always hears everyone talking about it, and it's pretty cool for AI and stuff like that.
Python is good.
Python, well, so Lisp was one of the first high-level languages like ever. So it came before Python. It was the first to introduce some of the concepts that Python holds so dear. It's amazing. So, but Python is amazing, right? Because there are libraries for everything. There are libraries for absolutely everything. There's absolutely nothing that you can think of that there isn't a Python library for. And if there isn't a library, you can write one pretty quickly. So I like Lisp, but I rarely use it because all of my API bindings and all my projects are in Python. And I'm not about to rewrite everything in Lisp just because I happen to like parentheses. And so in particular, I really like Closure. It has like some really great ideas behind it. And Closure is, it's amazing. If anyone doesn't know Closure out there, I suggest that you get familiar with it because it has some pretty neat ideas. And it'll change the way you program.
For Closure is a good place to start.
Mm-hmm. So I figured I want to make Lisp and Python work together, because why not? So I spent my entire winter break, my entire time off from work, working on this. Hi. So it's not professional, and it was written in my time off, so don't count on it being right. So Hi is a couple of things. Most importantly, it's a lexer, so it's able to take Lisp code and correctly process it into tokens. Basically,
How hard was that?
It was actually about 100 lines of code because Lisp is the most regular language you know. So unlike parsing Python or anything like that, that's hard. Lisp is insanely easy, and you just represent everything as like lists because that's you know what it's good at. And on the back end, it also takes that lex tree and turns it into a Python AST, which is Python's internal representation of Python. I will get into that later. Don't worry. Basically what this means by doing that is I can convert Lisp expressions into native Python. Let that sink in. I don't hear any oohs and ahs. I don't think anyone's paying attention because that is mind-blowing. So basically, like the code itself, Lisp actually becomes Python. It is as Python as anything else. Seriously, it's awesome. Okay, so at this point, people are probably questioning my sanity and wondering why I even want to start doing this, because Python, .py files, they work perfectly fine with the Python interpreter. So why am I wasting all this time? The first is because it's extremely I'm sorry. This is all a lie. I wrote this when I was trying to lie to you. I did it because it's fun. I think that counts as something.
Yes.
but people like using it for AI, and Lisp has something called macros that are amazing. And Lisp macros aren't like C macros where you can just pound define something. You write Lisp in the data structures that Lisp itself understands. So that means that Lisp basically is amazing at parsing itself. And that means that Lisp is very good at rewriting itself. So you can write little bits of code that alter the code trees programmatically. Yes?
I think what you're trying to say...
What am I trying to say? Please, save me!
You're trying to say that Lisp is extensible and Python is not.
See, I don't want to go there. I don't want to go there.
There's gonna be Python.
I want to go there because Python has ASTs, and Python ASTs are identical to Lisp macros in so many different ways.
Show us.
Yeah, abstract syntax trees. I'll get into that later.
Self-modifying code.
So basically, to get comfortable a little bit with Lisp, for those that don't know Lisp here, I'm going to go quickly because a lot of people raised their hands when they said they know Lisp. You write things in prefix notation up here. So it's where you do like plus 1, 1, 2 instead of 1 plus 1 plus 2. You declare the operator, and then you give it the arguments to that operator. Okay. So basically, if you'd write that as a Lisp S expression, which is how you express code, this is like a code statement, you'd say plus 1, 1, 2. Okay. So I wrote this little thing, this presentation in Impress.js. Yes?
The parentheses are now important.
Yes, I'm about to show you. Yes, absolutely. So, oh no, it's broken. Okay, I thought this was going to happen. Okay, this sort of works. I'm sorry that it isn't big enough. So I wrote this presentation in Impress.js. So I wrote these little things, which are like REPLs basically. The left side is Lisp, and the right side will automatically update to the Pythonic version of Lisp as I write it. Because it's easier to express
No
ideas like
way.
this. Yeah, way.
Show me.
I will show you. So if I edit my, oh my god, I can't see the screen. Okay, so if I add 3, 4, 5, you'll see on the right, it's 1 plus 2 plus 3 plus 4 plus 5. Amazing. Okay. Great. So we're going to get into the parentheses. So that just represents a statement. So this is to get you acquainted with it. This is the hello world. This is always Lisp, and that's Python. So whenever you see that, just know that's going on. So feel free to think in both directions. It's to drive the point home. I also, okay, so I'm sorry, I didn't answer your question directly, but it's coming up. I'm sorry. So I also added, which isn't common in other Lisp variants, except for closure, lists and dicts, basically. So lists basically are the parentheses, but they don't get evaluated. The first thing doesn't mean anything. Whereas with parentheses, the first thing means something, right? It's the operator that you're passing everything to. The lists, they're just like a data structure list. Very, very simple. And the dict is almost exactly like the Pythonic dict, right? You have key value, key value. You'll notice no commas. That's very common. That's how Lisps work. Clojure will ignore them. I chose not to because I really don't like commas in Lisps. So here's an example, right? We have on the left side, print 1, 2, 3, 4, 5, which is print the list 1, 2, 3, 4, 5, right? And on the other side, we have print the dict 1, 1 key, 2, 2 key, 1, 1 key, 2, 2 key. If I add another one in here, say we add 3 key, we can see that's added to the dict, and you'll see if, well, actually you won't see because errors are hidden. But if you have an uneven number of values in there, it's broken. So anyone have questions on what's going on right now with these lists?
Very nice.
Thank you, very nice. Okay, I thought so.
That's not a question.
Yes?
Those are not like Python Lisp expressions where you can have expressions being evaluated inside of them.
Do you mean list
Say
comprehension?
1, 2, 3, x, 4, 5, and x will
Replace the
be
number with an
substituted
expression.
in.
Replace, oh, you want me to replace a number with an expression? I can absolutely do that. And you'll see now we have foo calling bar, right? So you'll see this first operator foo is being applied on this argument bar, which is just foo calls bar, right?
Forgive me.
Oh, no, quite. That was a great question. I'm sorry for not being clear.
I love
Yes,
it.
question.
I think this is cool because whatever underneath, right? You're taking the list underneath representation and you're taking it to Python, right? It's not a straight syntax translation because I see the.
Yes, this is turning it into a Python internal representation and trying to make Python out of it. This has to do with some debugging code that Armin wrote when he was doing Flask. So it's kind of broken in some places, but it does a really good job. So I'm going to just trust that it generates decent Python. Other questions related to this? Questions, Bueller, okay. And so we can also, let's start getting to the fun parts, declare functions, because Lisp is really good with, it's very functional. You just use functions for everything. It's great. So here's how we define a function. Doc strings also work, so don't be scared off by that. So we're going to define a function, def, fn, right? That's really define a function. I'm going to call it square dash number, and we give it a single argument x, and we're going to return x times x, okay? So in Lisp, you don't return, it just returns the last thing in the code path. Questions on that, quickly?
Doc strings.
Dot strings work. I will also get to that later, so let's not worry about that.
Go.
So define foo as do, and we're going to print square number 3, right? And so this will return 9, unless my math is horribly wrong. Yes, quick.
Underscores are becoming.
Dashes become underscores because dashes are subtraction in Python, and you wouldn't really want to subtract those two things. So, okay. So I also added support for loops because the traditional way to do looping in Lisp is to use recursion, which is good, with tail call optimization, which basically is like a go-to that lets you go to the top of the function over and over and over. I just use for loops because they're in Python and they work really well, and I don't see the need in making things very complicated. So this is what a for loop looks like. I'm defining a list. This is a test for x in my list, right? Print x, right? So it's a little bit kind of weird syntax. Everyone got a handle on that? I'm sorry, I have to move a little bit quick because there are a lot of slides here and there's a lot of stuff.
Go.
All right. Imports, so Pythonic imports, so importing Python in Lisp works. Index accesses also work. So if I import this and print sysrv1, then I can print the first argument that's given to my Lisp file. And it's fantastic. And if I want to import something else, so let's say, what's something else that you know? Yeah, math. Oops. Okay, those are broken. Ignore that.
Now you know it's live.
Pay no attention to that man.
Right, so that will work. Okay, and then we can invoke them like pi math. Will that work? Math.py? Is that a thing? No. Yeah. Okay. It's not a function. This is going horribly wrong. Okay, I'm going to stop here before I start digging myself into a hole because I got more. And so I also have code branches working. So stuff like if 1 is true, 1 is equal to 2, then we have the true branch, otherwise the false branch. Obviously we can change this as we see fit. We could say if true, then print the true, otherwise print if false. What's that?
Did you do
Cond. I did not do cond because I'm lazy. But there is literally a bug filed on it. So if you want to +1 that, feel free. Okay. So I stuck to very Pythonic words so that people who knew Python could sort of survive in this. All right, and so something a little bit hardcore, in case anyone was getting bored by this, just want to spice it back up a little bit to see exactly what, like, if we push this as hard as it can go, what sort of awesome things we can have it generate. So I did this. I made decorators work, keyword arcs work, method call on arbitrary objects, function invocation, dashes turn to underscores. I also have other things like if I do def foo, which is Lispy for like something constant, it'll automatically turn to uppercase because that's very Pythonic. So this is what happens when you have too much free time on your hands.
Don't let this happen to you.
Yeah, no, this is a warning. Yeah, and the decorator works. So if I add something else, you can even invoke another argument, and it turns into the invoking style. So there are all sorts of crazy built-ins I added to try to get on par with Python here. The motivation behind this is because I wanted to write a Flask app, and so I was able to write Flask in Lisp, which was pretty sweet. Sorry? What's that? No. I also wrote Django if that was what you were complaining about.
No.
Okay, all right.
You're saying you don't think like things being complicated.
Oh, no. Okay, and so I even got tracebacks to work. So if you'll notice in this traceback, you'll see the Lisp is printed out instead of the Python in the Python traceback. Yes?
Is that a matter of decorating the AST?
That is a matter of correctly annotating the AST. So it's just saying my line numbers aren't totally wrong, which is good. So if you import a Lisp file in Python, invoke it, and it's throwing an exception, it will print out the relevant Lisp, which is awesome. It took a little bit of time. Yes, and back.
That's actually, Clojure doesn't do that. That's pretty
Clojure does not do that, because ClojurePy's implementation has some serious problems with it that I won't go into here. Okay, nice, good observation. I like that. High five for knowing ClojurePy. Okay, and so imports. That was a whole different mess that I want to talk about just quickly because it's awesome. This entire thing has just been awesome. So basically, I got imports working using PEP 302.
What is that?
Hey, good question, Ned. Thank you. PEP 302 allows for new import hooks, which basically allow you to hook on to the import lib stuff in Python 2.7 and above. And when the built-in importer in Python fails to find something, it will invoke your meta importer. Okay. So what some people thought that it would be funny to do would be if it fails to import it, it could search a website. So if you import org.anis.foobar, it would curl that URL, and if it was a Python script, download it and run it, right? Just for fun. This isn't no one actually used that because it's a horrible idea. But but it shows you what you can do with it because it's amazing. So this lets you sort of define fallback stuff, and you don't have to alter Python path, and you can get at all your usual stuff. It's amazing. So I abused it because I wasn't looking for things that were Py or PyC. I had a lot of time. That is also true. But basically, it goes through the entire Python path, and it finds anything that ends with .hi instead, or if it finds a package that's defined with .py. Hi, I'm sorry. Oh my god, this is terrible. So this basically means, as a result, okay, that wasn't what I was talking about. And so it will import the file. It will import that hi. It'll turn it into a Python AST and drop it into sys modules, which means that Python can import Lisp, Lisp can import Python, Lisp can import Lisp, and Python can import Python. Okay, everyone's all happy. This is where ClojurePy breaks down, because Clojure can import Python, but Python can't import the Clojure, because there's all sorts of wrappers around their objects and stuff like that. So this is pretty sweet, if you haven't gotten the fact that I'm super jazzed about it. It is actually the coolest thing ever. Amazing. Lets you do all sorts of really crazy stuff that Python developers had no, they had no idea that this was going to be going on. They had no idea people were going to be trying to do this stuff. So it's pretty great. So basically the importer consists of two parts, right? The importer and the finder. And they each serve a very specific purpose. Okay? The finder is in charge of actually finding out if the importer can actually import that file. Okay, so it'll search the Python path in our case, and it'll look for something that ends with .hi, given a full name, where a full name is something like os.path. So when you do import os.path, it gets passed to a finder, right? All the finders and meta importers, and it will run find module. If the return is anything but none, it will continue. If it's none, it'll bail out and pretend like it didn't exist. Questions on that? Because I feel like that's potentially complex. No one. Yes?
There's this whole complex set of rules for finding modules in Python, just in Python. And so you're doing the same thing, or is it doing it for you? Or underscore init.py and
Yeah, so
stuff inside
yes,
of
yes,
init.py.
it is magic. But you just have to append this class to sys._meta importers, I think. I can't remember the exact name, but I'm pretty sure it's meta importers. And so if it doesn't find anything using the built-in import methods, it will go through your meta importers and attempt to use them to load the module instead. Is that
Right, but
what you were asking? Or?
Is their stuff doing some of the work of finding the headers for modules?
Oh, no. I will go over that shortly. That's coming up. Okay, and so on the returned object that we return that's not none, that's called a loader. And the loader is responsible for loading the module, right? Loader.load module, given a full name like os.path or like MongoDB or whatever, and drop it into sys.modules. So here's what the finder and importer looks like. This is what you're asking, I think. So our importer, I'm sorry, let's go with the loader first. I'm sorry, let's go with the finder first. So what it does is it searches the Python path in find on path, and if it finds it, then it'll return a string. Otherwise, it'll return none. I've just taken that code out because it's a little bit confusing. But basically, goes through every directory on Python path, sys.environment or wherever it is, sys.path. Thank you, Ned. And if it's none, so if we didn't find anything on the path, then we're going to return none. Otherwise, we're going to return our meta loader, and we're going to instantiate it. Closure takes a slightly odd approach here, closure pi, but it's not relevant. Then our load module code here basically imports a file. This is some magic I'll get into later. This turns it into an AST. This turns it into native Python code blocks. Okay, and then it sets some fun stuff on that module, like if it's a file, who the loader was, which is ourself, the name of the module that we're importing. If it's a package, then some other relevant shenanigans. And then we're going to drop it into sysmodules, right? Sysmodules full name equals mod, which is where you'd expect it. Does everyone here know about sys modules? No? Yes? Yes? No? No one? No one? Is anyone listening?
Yep.
Yes? No? Okay.
We all know about it.
Okay, good. All right, great. So then we'll set it in sysmodules and return the module that we imported, right? So using this, magically things become importable that were never importable before. It's pretty awesome. I encourage everyone, like seriously, this talk isn't about you trying to use Hi. This talk about is like how great Python is, and you should be playing with this stuff because it's awesome.
Would you say it's extensible?
I would in fact say it's extensible. Thanks,
Nice.
Ned. It's a good word. All right, so let's back up to the AST things. Yes, quickly.
So when you import, does that actually do the translation to Python, or is the...
Yes, yes. I will. I guess I glossed over that, and it's okay. But it'll basically lex the code. It'll process the code, and it will turn it into AST. So it'll turn it into the abstract syntax tree, and it will return that sort of parsed tree, that internal representation of Python in Python, except it's Lisp. So basically yes. Basically yes. All right. So let's talk about quickly.
You parse that in, and you get the parse tree. Do you get back to the Python code from the parse tree?
You get to an AST, and you can generate Python code off the AST. Okay. So let's talk about ASTs, because I've been mentioning it a lot. ASTs, or abstract syntax trees, are the internal representation of Python in Python. Yodog. It's pretty great. So you can take arbitrary code in Python and programmatically alter it, which is something that Lisp is very good at. So this is like sort of one of those things that Lisp has influenced Python in, right? ASTs are definitely one of them. So I'm going to take a look at some of the AST generation code that I've written for Hi. This is going to go quickly. So pay attention at the beginning, and you can tune out at the end, because the beginning stuff is going to be a lot easier to understand. All right? Good. So this is what's generating our strings. Oh, I'm sorry. This isn't my strings at all. My slides are all wrong. So this is what an AST looks like. So given this function definition, def hello world, takes an argument x, and we're going to print hello x. This is what the AST, this is the internal representation of that function in Python. It's going to be a function def object, right, whose name attribute is hello world. It takes a list of arguments, which is named x, and it's a parameter, right? No variable length arguments, no keyword arguments, no default arguments, and then the body of our function, which is going to be print, right, print function, hello, and then x, okay? So, and then decorators if they exist. That was really quick. Anyone confused by what's going on there? Anyone confused? No one? Good.
Can we write our Python like that?
Yes, you can, but it would be a terrible idea, and there are inconsistencies between 2.7, like 2.6, 2.7, 3.2, and 3.3. They all have slightly different versions. And Jython too, if you ever want to. PyPy is actually pretty good about being very 270. So basically, Hi acts as the AST compiler, right? We take the Lisp code and we compile it into the AST bytecode, right? This is no different than what GCC does, because GCC just takes C and it outputs assembler, right? But instead of taking in C code and outputting assembler, we're taking in Lisp and outputting Python, basically. Great. So yeah. So that's Hi. It's basically the same function that we did before, but in Lisp. Just to get you guys comfy with this again, define a function, hello world, x, print hello x, same function body. Hint, it's actually the same function body. I might have copied it, so that might actually not be entirely true. But but I checked it, it works. Don't worry about it.
Question?
Yes,
Doesn't that
answer.
let function list return whatever the print function returns?
It should, but because the AST is so horrible, absolutely horrible to do that with, my code is also sufficiently horrible, and it adds returns where appropriate, and so it will not add a return on a print. If I had a 1+1, it would, but it's like not very consistent. I know that, and it's also outside. I'm not going to get into it because it's one of the things I'm very upset with this code, and I'll probably be changing it shortly. So yes.
So what did you write
quickly.
the ESD compiler in? What language?
Python. Everything's written in Python. In fact, almost none of Hi is written in Hi, which is embarrassing. So I'm probably going to also change that as well. So I actually had an idea to write the Hi interpreter using our Python from PyPy in our Lisp to create Hi. But okay, let's move on because this is just going down a bad path and we're gonna get nowhere. All right. So let's take a look at Hi's internals because I think the internals are pretty sweet. Basically, we sort everything at the beginning, at this sort of entry point where we're given a tree. We sort the object that we're trying to render based on its type. It's usually bad to do that in Python, but we're doing some really bad things here, so we're going to ignore that. And we're going to start shuffling off strings to a render string method, and we're going to start shuffling off functions, expressions, to render function, and we're going to start shuffling off bools to render bool, and that way we can keep this logic a little bit more contained without having a huge if-else, because I don't really like those. So here's the simplest possible one that I thought I was going to be talking about earlier, but I'm actually talking about now. So this generates strings. So given that node is a string, because our internal representation in Hi of the string is actually a string, we're just going to return an AST string with S, which is the value. That's part of like the AST itself, equal to the stringular representation of node. So this is possibly the simplest part of Hi. Does anyone have questions about this? Because if you don't get this, the rest of the presentation is going to be like garbage.
I'm so confused.
Oh no. So basically when we give it foo, right? When we give foo to this function, render string, we get this back. An AST string, S equal foo, okay? Extremely simple. Let's start wrapping this up. So here's, yes, quick.
Is there an internal tree-like representation of a whole expression before you turn it into an AST?
Yes, yes.
So this is transforming the individual pieces of the tree into Python.
Yes, exactly. It's a tree-to-tree conversion. So I take the source code, turn it into my internal representation of a tree, because it's a little bit more sane to work with than an AST. Although ASTs are great, don't get me wrong. You should all love ASTs. I just use my own, because that's what my parser outputs, and it's a little bit easier for me to code against that than an AST. And then it takes that, turns it into an AST, and in that little REPL thing, it then takes the AST and turns it into Python, but don't worry about that. That's not what it usually does. So let's take a look at what happens when we give a list to Hi. So in this render list method, we have our return value. I broke this out because the actual code's a little bit more confusing. This actually might be what's in Git now. This is Python. The entire, remember, the thing that takes the Hi and turns it into an AST is in Python. So for each value in our passed in node, because nodes is a list, because our internal representation of a list is actually a list, it's actually pretty sensible. We are going to append render C. So render will basically just call that render method again, and so it's almost like recursion, but it's not recursion because this is in render list, not render. Okay, I feel like I've explained that very poorly. Who's confused?
Just say it's magic.
Okay, it's pretty close to magic. And so we assembled the list object, right? We have ELTS elements is return, which is a list of other AST objects. And the context, which is load, because in all contexts that I've had lists, we're loading them, not storing to them, because I don't think you can store from lists. And so when given the following, 1, 2, 3, foo, to this function, because that's the internal representation, to the AST renderer, it's going to output Lisp elements num n equal 1, right? AST.num, it takes a number. Num n equal 2, string s equal foo, context load. Pretty boring. Is everyone still with me?
Go.
Okay, I'm seeing yawning. I like it. Let's go to dictionaries, which are only slightly more complicated. Wrapping it up here. So for each key in the value, we basically have to sort them into a key list and a value list. And that's actually how ASTs store dictionaries. If anyone else is mortified, you should be, because that's not very cool. But yeah, so we'll create an AST.dictionary, keys equal keys, values equal vowels, they're in orders. So we'll have 1, 2, 1 vowel, 2 vowel, so we see keys, dict keys, string 1, string 2, 1 value, 2 value. All right?
Are you
Yes.
using ordered dictionaries or?
These are not ordered, those are lists.
Right, but you're.
Python's internal representation of dicts represents them as lists.
Right.
An
okay.
AST.
And in AST, excuse
I
me.
understand.
Yes.
You're effectively making an ordered dictionary.
Essentially, but it doesn't treat them like that after it's been processed into a code block, I don't think. I'm not sure. Ned, you maybe know more about that than me.
I don't know.
Okay.
Go.
No one knows. No, don't worry about it.
I don't want to harsh your vibe. Let's just go.
Yeah, let's not harsh the mellow. So here we have render symbol, and a symbol is anything that we're like using symbolically. So like foo, bar that I was using before, just because I'm throwing around everywhere. Just some sort of abstract value. So like x equals foo. That'll be a symbol. So basically we have some logic in here that will return an AST.name. Name is a symbol, so it's like x, y, foo, bar. ID is equal to the string representation of node, because we just store them as strings internally, because I don't really care. Context, we're going to load it, return it, everyone's going to be happy. So given foo, we will get a name ID foo, context load. The only problem is here, when we're given something like foo.bar, it's actually given as a symbol on its own in high, because it's a little bit messy. So we just have to break it up, and we have to say we want the attribute of what we're rendering next. So we're just recursively render it. We break it apart and recursively render it. Everyone still with me? Okay, good. So we can use dotted notation magically in high, and everything will work, and nothing will blow up, hopefully.
And the symbol can refer to any other kind of function, or any other kind of?
A symbol can refer to almost anything in Python. Actually, everything in Python, right, I think. There's nothing that a symbol can't.
Any name can refer to any value at any time.
Yeah, that's right. Anything can do anything at any time. Okay, and so now let's start getting to the fun things. Function definitions, stuff like that, because this is going to start getting a little bit gnarly. So here's when we invoke something. Yeah, all right, thanks, yeah. I worked this on a weekend, come on. All right, so when we're rendering an expression, so we're invoking foo or we're invoking bar or something like that, we get node. Node is a list, okay? So just like it's represented everywhere else in Lisp, we actually get an actual list. The first argument, fn, is going to be the operator. So it's like plus 1, 2, 3, 4. That's going to be a plus. It's not actually because of optimization layer. Don't worry about it. And then we get all the arguments to it. So we can construct our invocation of the actual function itself. So this is just a wrapper I wrote to split it on the first value. It's kind of embarrassing to have a function for that, but I do. And so we'll get the function if it's in our native cases. So if it's something like if, like the if statement, because we don't want to evaluate both sides, we can pass everything as it is now and return what that returns because it's another part of the internals. Otherwise, we want to continue down the tree and render everything from inside out. It just has to do with the structure of Lisps in general. This just makes things a lot easier. So this basically says if it's an internal symbol, if it's a special form, then we're just gonna process it and be done with it. This is starts with, don't worry about this. This is some things I added to do method calling on anonymous return values. So basically it lets you, yeah, don't worry about it. It's like a dot foo notation. I'll show you later. Otherwise, we have the children that we have. And for child and children, so for all the children that we have in our expression, we're gonna recursively render it. Well, sort of recursively, basically recursively. If the function's in special cases, then we're going to let the special case handle it. It's a little bit different than a built-in. Not going to get into that differentiation right now, but again, more special casing. Otherwise, we're going to actually render AST again. So this is where things start. This is a mistake. Don't read that. That is wrong. Sorry, that value doesn't need to be there. So basically, we'll render an AST.call. Function is equal to the actual function, so we're going to render the symbol of that actual function that we had before. Args is the children that we were building up over here. Keyword args, we don't have any because we don't have any way of expressing keyword args yet. Star args, keyword args, everything's pretty simple there. So this is how we render a function call. This is a little bit more intense. Everyone's still kind of roughly cool? Okay, cool. We're all cool. Everyone's cool.
You're hot.
I am in fact. All right, and so this is how we define a function. This is starting to get a bit more dirty. So if you remember our syntax, the defn, the defined function, we're given that into the invocation. So basically, we have the name of the argument, so def fn foo. We're going to pop that off. We're going to pop the signature off, so that was the square bracket x or something like that. And then we have the rest of the body. We declare the doc string. If our first child is a string, then we just treat it as a doc string, which is helpful for native Python interoperability because you like to document things, and everyone here should have doc strings in all their functions anyway. So you should be asking me how you do doc strings in Lisp, not whether or not we have them. And so for each, yes. So then we're going to render out the code underneath that particular defined function. By doing that sort of recursive method again, we're going to take the child and we're just going to sort of dispatch it, have it render out, and then we're actually going to deal with it down below. This is all just sort of special casing shenanigans, but basically we end up with a function definition. We're going to name it, which is the name of the function, so we're like def foo, right? Def square, def whatever. We're going to have the arguments, so that's the name of the arguments. It's an argument list, that's what's in the parens. So we have like x, y, whatever. We're just going to render out a name for each element in the signature. It's just list comprehension, don't be afraid. Another thing taken from Lisp that is amazing. Var args, keyword args, keyword only args, keyword defaults, defaults. So actually, the way it generates these is there was a slight change in Python 3 and Python 2, so AST representations and function definitions. So hi actually just auto-populates everything because the keywords don't like conflict. So you actually get an AST that will work in Python 2 and Python 3, which is pretty slick. So I like that. It's pretty amazing. So that's why there's like a little bit of duplication there because keywords changed. It's pretty sick. Okay. So let's take a look at another bit of generated AST. So if we look at square, give it a number, we're going to return number times number, right? So we're going to have a function definition, name square, our arguments, we're going to have number, right? Square, number, number. And then in our body, we're going to return. So here the returns are working. I see that you're bored, I'm sorry. So we have the actual return stuff working here. We have the binary op of number multiplied by number in the body. So there's some mangling that has to do with finding the end of code branches that kicked in there, which was awesome. Decorator list, empty. We are not decorated. Okay. And so here's how we do that decorating that I was showing off before, because I think that's also worth explaining because it conveys an even awesomer topic, which is actually why AST is useful in some cases. So what we do here with our decorate is we have the stuff that we want to decorate with, right? It's all the arguments except for the last one. So we're going to pop the -1th element off the back, and we're going to have everything else. And then for each child in all those symbols, so for all the symbols that were given to that function, you're going to access fn.decorator list. So if you take a look up here on the function definition, we have that decorator list. You can programmatically add stuff to the like parent. So when you're getting a defined function, you can just start shoving stuff into the AST that you were given. You don't even care. So what this does, this keyword args decorator thing, is it just starts shoving stuff into that keyword args, even though we have no way of actually really expressing keyword args in Lisp. So it's another special form that lets you do special things in special ways. Is anyone confused by this? Because this is a cool topic. Yes, again.
What did you just say?
Okay, I started to see glazed eyes. So you represent the majority of people in this room, I'd imagine. So basically, when this function right here, when we get fn, so that's doing that render. So this is rendering that function that we got. So if we take a look again at the syntax here, so if we have something like square. Oh, sorry. That's better. So if we have a function called square, right, and we're returning, or actually, that's silly. Why am I doing this? That's not what I was doing at all. Okay. No. So okay, the keyword args thing that I was talking about. If we're invoking foo, and foo takes. Actually, how many people here know Flask? Does everyone know Flask? Okay, almost no one knows Flasks. So if I call foo with bar, this roughly translates into foo bar, right? Everyone still with me? Lisp on top, Python on the bottom. So if I want to do foo bar, baz equal 1, okay? How do we represent this when we only have lists? It becomes incredibly complicated. So what I wrote was decorate with, and I can decorate with as one, right? And then this guy, that's how this works. So basically, it will take this invocation here and add some bits to it. Actually, I've screwed this up. That needs to be.
Basically, you're doing a closure in Lisp.
Basically. Hold on, sorry guys.
We're going to wrap this up soon.
Okay, I'm gonna get through the rest of my slides because basically memes. Everyone laugh again. Okay, things are no longer scary. I'll get back to it in a second. So basically, we're playing around with ASTs because ASTs are awesome. And so let's just shortly cover how to turn ASTs into real code. I've started off on a digression there, and that was that place to finish. So basically, Python has a built-in thing called compile. And compile will take an AST or plain Python expressions and turn it into a code object, which is actually like runnable. And Tom, who's sitting in the back there somewhere, was working at one point at turning code blocks into PyCs, so we could have high C to turn Lisp into PyC files. And no one would ever know that there was Lisp involved ever, because there's no dependency on high itself. Basically, that code object is then passed to eval, and eval will let the Python virtual machine actually evaluate and run the code. So here's what it's doing to turn high into Python and evaluate it. Basically, it imports the new module, it sets the file, it doesn't need to, that's just a nicety. Then we're going to create the AST with this forge AST, which is going through all that craziness that I just glossed over that everyone's a little bit confused by, so I'm sorry about that. Basically, it'll take the Lisp itself and turn it into a Pythonic AST, and then it will eval the compiled AST, given its like file path, which is used for tracebacks and lookups, and we want to execute it. And then we're also given the context in which to execute it, so we're given this module.dict, which is its namespace stuff. And then we're going to return the module after we're done with it. And this will basically forge a Python module out of Lisp. Sweet. Okay, quick questions. Yes.
You did some cool stuff with having tracebacks.
Yes.
How about PDB?
PDB
Like, you know, the step through.
will probably blow up horribly.
Yeah.
I have not tried,
Right.
but I can't imagine it would go well.
It probably will work.
So it generates AST in its code. So it can probably step through perfectly fine, but I'm thinking it's gonna have some sort of like something that's gonna confuse everything, and everything will just be
If your
there.
tracebacks are working, it'll probably work because all your line numbers will get copied into the code objects
Okay.
properly.
Yeah.
So it probably will work.
Okay, so it probably will work. We can try after. I'd like to know if that works because I don't use PDB. Yes.
Have you ever considered running it in Jython? That way
Okay, so I actually have. So this is like gone horribly wrong, right? Because Clojure is implemented in Java. Clojure Py is for Python, right? And Jython will let you run Python in Java. So I was thinking about running Clojure Py in Jython. In Jython to access like Python internals, but still have real threading. It went terribly wrong. Jython's like AST is at 2.4 or something like that. It's Python in general is like 2.4. So everything just broke terribly. Not to mention it doesn't work with virtual env because of like hard-coded paths. But it's on my to-do list.
So you're saying I can't currently go from Lisp to Python to Java?
If you try hard enough, I'm sure you could. We'll talk. Yes.
When you were doing the demo at the beginning and things were breaking,
Yes.
is it because you didn't have enough of the function calls defined, or when you were going through each module, like defining a square function, defining a function call, AST?
I just I didn't know what I was doing. So I outputted garbage on the screen, and I was a little bit frazzled because I'm not really thinking right now. I'm just going off instinct.
The compiler you wrote, it wasn't complete, or it wasn't.
The import thing is what you're talking about.
Yeah, no.
Yeah, no, that was the cogen stuff. The cogen just barfed on that. It doesn't like single line stuff.
And that's a Python feature from AST?
No, this is something Armin wrote when he was writing Flask to debug templates.
Oh.
So the fact that this is working is like a miracle.
Okay.
Yes, in the back. You on the left.
Is it
specific to a certain version of Python because you're going to ASTs and ASTs are?
That is a brilliant question, and Ned told me not to do this because, well, no, you didn't tell me not to do this. You told me to do it a better way, okay, which I did. It was fantastic. But basically, yes, the AST varies completely between different implementations and different versions. However, the generated AST on this works with CPython 2.6, 2.7, 3.2, 3.3, PyPy, and something else that I've forgotten. So it does pretty well for itself. So it's close enough where you can generate like really kludgy stuff, and it'll probably work.
Yeah, well, then how did you pull off that trick?
Because they have non-conflicting keyword arts and like attributes. So if you just populate all of them, then you don't have to worry about it. Cool. Yes, in the back.
So if I understand correctly, your Lisp doesn't have semantics of its own, they're all determined by Python?
No, it does have semantics of its own. As a matter of fact, like all the implementations have to go through that compiler at some point, otherwise it'll default to a function call. So the one thing that it doesn't have now is macros, and that's like a big problem because Lisp should always have macros. But for instance, like if you saw when I was doing that true false in that if statement, I used a lowercase t true because that's idiomatic to Lisp.
Semantics like variable scope, shadowing.
Yes, those are all identical to Python because it turns into a Python AST. Yes, sorry, misunderstood.
So on your blog, you said this is the most horrifying thing you've ever done.
Yes.
It's awesomely horrifying.
Thank you. I appreciate that. Really.
Or maybe it's horrifyingly awesome.
I wonder how many permutations of that we can get into. Okay, and to wrap this up, because I see everyone's getting a little bit sort of.
We gotta get our free beer.
We gotta get free beer. I just wanted to make one point sort of known about this. So this is all running on a local Flask app. Flask, as you know, is written in Python, and as a result, I've been able to write it entirely in Lisp. So the thing running that presentation, including the REPL and stuff like that, that was all done in Lisp. The entire backend, including Pigman's translate, everything like that. Everything works pretty great.
High to Pi.
High to Pi does exist, yeah, and high to Pi color. So it isn't entirely silly. It worked enough to not blow up on me today, which I think is commendable. So,
Nice.
all right.